Have you ever poured hours into building an automation workflow? Seen it work just perfectly in your test environment,
Oh, yeah. Flawless.
only for it to just fall apart the moment it hits the real world.
Happens all the time, like that sandcastle analogy you used. Looks great until the first wave.
Exactly. So today, we're diving into how to build systems that don't just work, but, well, systems that survive.
Yeah, we're talking about taking your automations from looks good on my laptop to bulletproof in the wild. We'll unpack 5 core
Yeah,
techniques.
5 techniques. Okay.
Yeah, to make your workflows resilient, visible, and, truly professional. It's kind of like giving your automation a superhero cape. Or maybe a suit of
A
armor.
suit of armor, I like that.
Yeah.
We'll cover everything from centralizing error reports to smart retries, even backup AI models.
Hmm.
Think of it as a playbook for peace of mind, transforming those workflows from ticking time bombs into robust, production-ready powerhouses.
That's the goal. No more midnight alerts, hopefully.
So the core challenge, it feels almost philosophical, right?
Yeah.
Building something in a sterile test lab is, well, easy compared to the real world.
It is.
Yeah.
Because the real world is messy. Users do weird things,
Yeah.
APIs go down, servers just have bad days.
So what's the biggest hurdle when moving from that lab to production?
It's realizing that production ready doesn't just mean it worked when I tested it. Not even close.
Right.
It means building an anti-fragile system.
Anti-fragile. Okay, what does that mean exactly?
Yeah.
Different from just robust.
Yeah, subtly different, but important. Robust resists stress, stays the same. Think a strong wall. Anti-fragile actually gets better from stress, from errors, like our immune
Excellent.
system, it learns, adapts.
Okay, so it involves what? Handling failures gracefully.
Gracefully, yeah. Without total collapse, you need instant notification when something important breaks.
Okay.
You need an intelligent logging, so debugging isn't guesswork.
Hmm.
And crucially, a built-in plan B, retry logic, fallback logic.
Plan B. Always need a plan B.
Absolutely.
Well-
And it needs to fail safely. No bad emails sent, no critical data deleted by accident, because, look, failures are inevitable.
Right, you can't stop every single one.
Exactly. The job isn't to prevent all failures. It's to build systems that fail intelligently. That's the shift.
So the core shift in thinking when aiming for production ready,
Yeah.
what is it?
It's about expecting failures and building systems that adapt rather than break.
Expecting failures, building systems that adapt.
Mhm.
Got it. And to do that, we're using this onion or suit of armor idea, these 5 techniques, as layers.
Yep, layers of protection. We've got error workflows, retry and failure, the fallback LLM, continue on error, and polling.
Okay, let's peel back that first layer then, or maybe buckle on the first piece of armor. Error workflows. You said this is fundamental, non-negotiable.
Absolutely foundational, because the big problem here is what we call the silent killer.
The silent killer sounds ominous.
It is. A standard workflow often fails quietly. Imagine an automation processing new leads every night. If an API changes or a credential expires, poof. It could silently drop leads for days, weeks even. You don't know until sales complains.
Yeah, that's bad. Very bad. So the solution,
A centralized mission control for errors. Think of it like a single security desk for your whole n8n operation or whatever tool you use.
a central hub.
Exactly. All error signals pipe back to this one place.
How do you build that mission control? Is it complicated?
Surprisingly simple, really. 2 steps. Step 1, create the emergency response team workflow. Just uses an error trigger node. Its only job is to listen for errors.
Okay, listening for trouble.
Step 2, connect the red phone. In every single one of your active workflows, you go into settings and point its error output to that new error workflow.
Like installing an emergency line everywhere.
Precisely. Step 3, design the alert and log protocol. The error workflow grabs crucial data workflow name, error message, which step failed, maybe even the input data.
All the content.
Right. Logs it somewhere central, Google Sheet, Airtable, a database, and sends smart notifications. Slack, email, whatever works for your team.
Okay, I can see that. We had an issue once. An Airtable credential failed silently. Took ages to notice from weird reports. How would this have helped?
Instantly. Instead of silent failure, you'd get a Slack message like, "Sat n8n workflow, error, set workflow." Telegram, AI assistant. Failing node, AI agent, error, node operation error, with a link straight to the failed run.
Wow, okay. Actionable, immediate.
Totally changes the game from detective work weeks later to a fix in minutes.
And you mentioned a pro upgrade. Tiered alerting.
Yeah, because not all errors are DEFCON 1, right?
Sure.
A payment failure. Big deal. A channel alert now. A minor summary task failing. Maybe just log it to the sheet. You use a switch node in the error workflow to route critical errors to high priority alerts and non-critical ones to just logging. Keeps the noise down.
Smart. So what's the biggest danger if you skip this whole error workflow step?
Losing data silently and not knowing your automations are fundamentally broken.
Losing data silently.
Ah.
Yeah, you definitely want to avoid that. Okay, foundational layer sorted.
Mm-hmm.
Now, technique number 2. This one sounds almost too simple. The turn it off and on again button. Retry on failure.
Yeah, it sounds basic, but honestly, a huge percentage of failures are just temporary blips. Network glitches, server overload for a second.
The hiccups.
Exactly. Amateur workflows just give up. Professional ones, they retry. It's often the first and, frankly, most effective line of defense against those transient things.
And setting it up is easy.
Super easy. Most automation tools, like n8n, have it built into almost every node. Just find the settings for that node, toggle retry on fail to on n.
Okay.
Then you set max tries, maybe 3 to 5 is a good starting point, and a wait time between tries, like 5 seconds. That's usually it. 2 clicks, 2 numbers.
Handles most of those temporary issues.
The vast majority, yeah. But there's a bit of an art to it, depending on the task.
Strategy. Okay, tell me more.
Well, for calling external APIs, maybe 3 to 5 retries with a 5-second delay is good. Gives their server time to recover.
Makes sense.
For AI models, maybe 2-3 retries, 5-second delay. If it fails 3 times, it's probably a bigger issue than just a blip.
Right.
File operations. Those often fail because the file is temporarily locked, so maybe 5+ retries, but with a very short delay, like 1 or 2 seconds.
Okay, tailored to the type of potential failure. You mentioned an OpenAI hiccup example. How does retry actually play out there?
Right, so imagine OpenAI's server gets slammed for like 30 seconds. Your workflow makes a call, gets an error.
And the amateur workflow just stops. Dead.
Yep, but yours. With retry on fail set to 3 tries, 5-second delay, it fails, waits 5 seconds, tries again. Maybe fails again, waits 5 seconds, tries a 3rd time. By now, the spike is over, the call goes through.
And the workflow just continues like nothing happened.
Exactly. The end user or the overall process is completely unaware there was ever a problem. It just smoothed itself out.
That's pretty powerful for such a simple setting. And there's an even more advanced version, exponential backoff.
Yeah, this is what the big players like Google and Amazon use. Instead of waiting the same 5 seconds each time.
You wait longer.
Exponentially longer. First retry waits 5 seconds, second waits 10, third waits 20.
Giving the server more and more breathing room.
Precisely. Especially crucial for mission-critical APIs that might be under heavy, sustained load. Whoa. I mean, imagine the resilience that gives you when you're handling millions of requests. It's smart scaling.
So for most external services, how many retries are usually enough?
3 to 5 attempts with a short delay often solves most transient issues.
3 to 5, short delay, good rule of thumb.
Yeah.
So retries handle the blips. But what if it's not a blip? What if, say, OpenAI is just down, like really down for an hour? Retries won't help that.
Correct. That's when retries run out and you need the next layer. You need a plan B, a real backup.
The Fallback LLM.
Exactly. The AI's backup singer analogy. Your main AI, maybe GPT-4o Mini, is your star.
Yeah.
But if they suddenly lose their voice,
The show must go on.
the show must go on. So you have another capable AI, maybe Claude 4 or Google Gemini, waiting in the wings, ready to take over automatically.
Okay. And setting this up, is it in the node settings too?
Often, yes. In tools like n8n's AI agent node, you'd first make sure retry and fail is on. Then there's usually a checkbox like add fallback model.
Right.
You check that, and it lets you connect a second, different AI model.
Different is key here.
Absolutely critical. The golden rule is diversify providers.
Why?
Because if OpenAI is having a major outage, switching to another OpenAI model probably won't help. They might share the same underlying problem.
Same infrastructure.
Exactly. It's like having a backup generator that runs on the same potentially disrupted power grid. Useless. You want your backup on a completely different fuel source.
So primary OpenAI, fallback Anthropic or Google. Makes sense?
Yeah.
Or if you use an aggregator.
Like OpenRouter. Yeah, maybe your primary is via OpenRouter, and your fallback is a direct connection to Google Gemini. Bypasses the middleman entirely.
You mentioned testing this by deliberately breaking the primary key.
We did. Gave the primary AI a bad API key. It failed. Retry kicked in, failed again.
Expected.
Then, automatically, the system switched to the configured fallback model Google Gemini in our test.
Yeah.
And Gemini processed the request successfully, the workflow completed, the end user just saw a slightly longer pause, no error message, seamless failover.
That's impressive.
Yeah.
But you also mentioned a challenge, prompt drift.
Yeah. It's something I still wrestle with, honestly, even with fallbacks. When you switch from, say, GPT to Claude, even with the exact same prompt.
They might interpret it slightly differently.
Exactly. Different architectures, different training data. You can get subtle shifts in tone, style, maybe even how it emphasizes certain points. So the failover might be seamless technically, but you still need to test and maybe tweak the prompts for your fallback model to ensure the output quality and brand voice stay consistent. It's an ongoing tuning process.
Good point. Consistency matters. So why is it so important to use a different AI provider for the fallback?
To ensure your backup isn't reliant on the same potentially failing infrastructure as the primary.
Different provider, different infrastructure.
Got it.
Okay, next layer. Technique number 4. Continue on error. You said this is a personal favorite for pros?
Oh, yeah. Especially for batch processing, it's a lifesaver. Think of it as another vital layer of armor.
Okay, so what's the problem it solves? You called it the assembly line shutdown.
Right. Imagine that content factory again. Pulling 1,000 leads, researching each, adding to CRM.
Yep.
What if lead number 3 has some weird character in its data that breaks the research step? In a normal workflow.
The whole thing stops dead at number 3.
Exactly. One bad apple spoils the whole batch. 997 perfectly good leads never get processed because of one tiny error. Huge waste.
Okay, that's inefficient. So continue on error prevents that.
It builds a smart assembly line. Instead of shutting down, it intelligently pulls that one defective item off the line for inspection, while the other 999 keep moving smoothly.
How does that work in the tool? Are there different modes?
Typically, yes. In most node settings, you'll see error handling options. One might be just continue, which basically ignores the error and moves on. For low-stakes stuff, maybe.
But not ideal.
No. The professional option is usually called something like continue using error output or similar. This is the game changer.
How so?
It doesn't just ignore the error, it creates 2 separate paths out of that node. A success path for items that worked.
The green lane.
And an error path for the specific item that failed.
The red lane.
Exactly. It isolates the problem child without stopping everything else.
You tested this with Google, Meta, and a deliberately broken NVIDIA entry.
Yep. Put quotes around NVIDIA to make it invalid JSON. Without continue on error, it would process Google Meta, then crash on NVIDIA. Stop.
Right.
With continue using error output enabled, Google and Meta processed fine, went down the success path. NVIDIA hit the error.
And instead of stopping.
It got routed cleanly down the error path. The workflow itself kept running for any subsequent items. 99.9% success, 0.1% oscillated for review.
That's incredibly useful for large data sets. And the pro upgrade here. Self-correction.
Yeah, this is where it gets really cool. That error path doesn't just have to go to a log or a notification.
It can trigger more automation.
Exactly. It can lead to its own mini workflow. Maybe it tries sending the failed NVIDIA item to a different AI model with a simpler prompt, or uses a different lookup tool.
Trying to fix the problem automatically.
Right. And if that fix works, the result can then be merged back into the main success path downstream. That's peak self-healing.
Wow. Okay. So how does continue on error help most with large data sets?
It processes good data efficiently while isolating problematic items for separate handling.
Isolates the problems. Very smart.
Okay.
Okay, final technique. Layer 5. Polling. Sounds patient.
It is. This one's key for asynchronous tasks. Stuff where you ask for something and the answer is an instant, like generating a complex report or a big AI image.
Right, things that take time. What's the problem without polling?
The agony of guess and wait. You kick off a job then? What dough? Add a wait node for 5 minutes, 10 minutes.
You're just guessing how long it'll take.
Exactly. Guess too short. Your workflow tries to grab the result before it's ready. Failure. Guess too long. You're just sitting there wasting time and resources. It's fragile.
So polling is the fix. The pizza tracker analogy.
Perfect analogy. You order a pizza, you don't just stare at the door guessing when it arrives. You check the tracker app. Making, baking, out for delivery.
Okay.
Polling is that tracker for your automation. It asks the service, are you done yet? Are you done yet? And only moves on when the answer is yes.
So how does that look in practice, say, for AI image generation?
Typically a few steps. Step 1, initial request. You send the POST request to start the image job. The service replies with, like, a task in status, queued.
Okay, order placed.
Step 2,
Mm.
initial wait. Don't pull immediately. Give it a reasonable time to start, maybe a wait node for 40 seconds. Let the chefs start working. Step 3, the status check loop. This is the core. It's usually a loop containing an HTTP request node to get the status using the tasked, an IF node to check if the status is still processing or if it's completed, and another wait node, maybe 20 seconds before checking again.
So it keeps checking every 20 seconds.
Yep. Get status. Is it completed? No. Wait 20 to get to status again. It repeats until the IF node sees completed, then the loop breaks, and the workflow continues with the finished image data.
Clever. Are there best practices for this? Golden rules.
4 main ones. 1, set a reasonable initial wait. Don't hammer the API immediately.
Okay.
2, use sensible check intervals. 15-30 seconds is often good. Don't check every second unless the API docs say to.
Be polite to the server.
Exactly. 3, always have a maximum retry limit on your loop. An escape hatch. What if the service breaks and never reports completed? You need the loop to stop eventually, maybe after 10 tries, and go down an error path. Prevents infinite loops.
Crucial escape hatch. Got it.
And 4, understand the API's status vocabulary. Read the docs. Does it say processing, running, pending? Does it say completed, succeeded, done? You need to know the exact words to check for.
Read the manual. Okay, and there's an alternative to polling. Webhooks.
Yeah, the more modern, often more efficient way, webhook callbacks.
How's that different?
With polling, your workflow keeps asking, are you done? With a webhook callback, when you make the initial request, you give the service a unique URL, your n8n webhook URL. You basically say, call me back at this address when you're finished.
So the service calls you.
Yep. Your workflow then just sits at a wait for webhook node, doing nothing until the external service sends the completed result back to that URL. No loop, no constant checking. Much cleaner if the service supports it.
More efficient. So what's the main benefit of polling over just guessing wait times?
It ensures you proceed only when data is truly ready, avoiding premature failures.
Ready and waiting. Makes sense. Mineral mention refer to separate script. Okay, so we've covered these 5 specific techniques, these layers of armor. But you mentioned there's a broader approach too, the guardrail mindset.
Yeah, it's kind of the philosophy that ties it all together. Because fundamentally, you don't know what you don't know.
Meaning?
Production environments are chaotic. You'll encounter weird data, unexpected API responses, edge cases you never dreamed of during testing. You can't predict everything.
So the mindset is about
being proactive and learning from the chaos. It's a 3-step process, really. First, log everything. Use that error workflow. Maybe add more logging. Capture every error, every weird pattern.
data.
Second, identify patterns. Don't just let logs pile up. Review them regularly, maybe weekly. Look for common issues. Is a certain type of input always causing trouble? Is one specific third-party API flaky?
Find the recurring problems.
And third, build targeted guardrails. Based on those patterns, create specific fixes. Like, we saw lots of failures because an AI was outputting slightly malformed JSON. So we built a guardrail, a little code node right after the AI call that specifically sanitizes the JSON output, fixing common issues before it gets sent to the next API.
Ah, a custom fix for a known problem pattern.
Exactly. That one little guardrail turned a workflow that failed maybe 10% of the time into one that succeeded 100%. That's the guardrail mindset. Learn from failures, build smarter defenses.
So let's put it all together. An example, a content research and generation system. How would all 5 layers work here?
Okay, imagine that system. Layer 1, error workflows. All errors go to a central log. Critical failures ping Slack immediately.
Visibility, check.
Layer 2, retry on failure. Every external API call research tools, AI models, is set to retry 3 times with a 15-second delay.
Handles blips, check.
Layer 3, Fallback LLM. The primary AI, say GPT-4 Mini, has Google Gemini Pro configured as its automatic fallback if it fails consistently.
Plan B for AI, check.
Layer 4, continue on error. If the research step fails for one specific topic out of 20...
It doesn't stop the other 19.
Right. That one failed topic gets routed to a separate manual review list. The rest continue.
Isolates problems, check.
Layer 5, polling. After the AI generates the content for each successful topic, which might take a minute, a polling loop patiently waits for the completed status before saving the content and moving to the next topic.
Waits intelligently, check. All 5 layers working together.
Yeah. The result isn't just a script that runs, it's an anti-fragile system. It handles partial failures, gives you visibility, maximizes the work that actually gets done successfully.
That makes a lot of sense. So wrapping up, the core big idea really seems to be failures aren't just possible, they're going to happen.
They are inevitable, yeah.
And the professional edge isn't building systems that never fail, because that's impossible. It's building workflows that fail intelligently.
That's it exactly. Achieving resilience, visibility, and what we call graceful degradation, failing partially but effectively.
Amateur scripts might look good in tests, but break easily under pressure.
While professional workflows assume failure and handle it gracefully. That's the difference, and that leads to actual peace of mind. You trust your systems.
And the implementation. People don't have to do all 5 layers at once, right?
No, definitely not. Start with the air workflow. That visibility is key. Then add retry on failure to most nodes. That's usually easy.
Okay.
Then maybe the fallback LLM for your critical AI steps. Then look at continue on error and polling where they make sense for your specific flows. And always keep that guardrail mindset, review logs, build targeted fixes.
Start simple, layer it up, analyze, and adapt. We really hope this deep dive gave everyone a clear roadmap for making their automations truly robust. What stands out to you most about building these resilient systems?
For me, it's the shift from hoping things don't break to knowing you have systems in place to handle it when they inevitably do. We encourage everyone listening, just pick one technique, start there, add that first layer of armor. Even that small change can make a huge difference.
Thank you for joining us on the deep dive.
Yeah, thanks for listening. And remember, the real pro edge, it's deploying automations, knowing they can handle the messy real world, letting you kind of forget about them, and most importantly, sleep soundly at night. OTRO music.